All right, guys, let's talk about chemical formulas. Chemical formulas are an everyday part of chemistry class. You've probably seen them before and you're familiar with a few of them already. So let's talk about what a chemical formula is. It's a series of chemical symbols, and it tells you a couple of things. It tells you what elements are present in a compound, and it tells how many atoms of each element there are in that compound. And so this becomes really important later in chemistry to be able to count how many atoms of each element there are based on the chemical formula. And so let's get some practice with that. So here's a formula that you're very familiar with, I'm sure, H2O. This is water. It's our life force, if you like. So what we have here is the symbol for hydrogen and the symbol for oxygen. So we know that hydrogen and oxygen are present in the compound. And then the other part of this formula tells you the number of each element that's present, number of atoms of each element. So this little 2 that dangles down here behind the hydrogen symbol, that is called a subscript. And it's attached to the element symbol directly behind it, and it is only applied to the element that it is directly behind. So the 2 here is only connected to the hydrogen and not the oxygen. So a subscript only applies to the thing directly to the left of it, okay? So if you run across a chemical formula where one of the elements is not subscripted, so without a subscript, it means there's just a 1. So anytime you don't see a number, just assume it's a little imaginary 1, okay? And we don't usually put a 1 there. It's just sort of known that if it's not there, it is a 1, okay? So that's chemical formula. Let's do some practice with our chemical formulas. This one we just kind of went through, so I'm not too worried about it. So we have 2 hydrogen atoms, 1 oxygen atom for a total of 3 atoms in a molecule of water. Okay, here's one, sodium chloride, and here we don't have subscripts on either of the 2 element symbols, so that means there's just 1 sodium atom and 1 chlorine atom, and this is a total of 2. Okay, how about this one? Here's one with 3 elements present. This is called potassium phosphate, and here we're going to apply the subscript 3 to the K, which is potassium, and so we have 3 potassium atoms. Phosphorus, the P, how many atoms is that without a subscript? You got it, just 1. And then, of course, 4 oxygen atoms, so this is a total of 8 atoms. Okay, so understanding chemical formulas is not terribly hard, but it can be a little bit more complicated if the chemical formula is a little bit more complicated. So here's one that you're going to start seeing a little later here. This is where we have parentheses that are part of the chemical formula. And so when we have parentheses and then a subscript that is outside the parentheses, we call that an outside subscript. And just like our former rule, the subscript is only applied to these things that are directly to the left of it, okay? And the parentheses indicates that PO4 is one thing, okay? And so when that happens, the outside subscript will multiply by the inside subscript. And so when I say inside subscript, I just mean it's any of the subscripts that are inside the parentheses. Okay, so let's take a look at how that goes. So we're gonna assume that we have 3 magnesiums here. That little 3 will attach just to the magnesium, but this 2 will actually distribute to all subscripts inside the parentheses, okay, by multiplication. That's what distribution is, if you remember from algebra class. Okay, so when we distribute the 2 to the phosphorus and the oxygen, we end up with, well, we already said magnesium has 3 atoms, but phosphorus, how many phosphorus atoms? If we multiply the 2 by that little imaginary 1, we get a 2. And the 2 will also multiply by oxygen's 4, and that is 8. Makes sense? Let's try a few more of those since they're the most complicated kind. So aluminum does not have a subscript here. That means it's only a 1. Here we have oxygen and hydrogen inside parentheses, but neither of them have a subscript, so they're subscripts of 1. So we're going to distribute the 3 to the hydrogen and to the oxygen. So each of those elements has 3 atoms, okay? And that's, what, 7 total? Let's try some more here. Here's one with calcium, nitrogen, and oxygen. Calcium without a subscript is 1. Nitrogen is we're going to distribute the 2 to the nitrogen, so there's 2 of those. We're going to distribute the 2 also to the oxygen, of which there are 3, and so we have 6 oxygen atoms, and this is 9 total. And one more just to kind of solidify ourselves here. Occasionally, very occasionally, you're going to see parentheses around the first part of the chemical compound, but the rule is still the same. If there's an outside subscript, it factors to everything inside and to the left of that set of parentheses. So here we're going to factor the 2 to the 4 and to the 1 on the nitrogen. So we have 2 nitrogens, 8 hydrogens, and then here we have our next elements, right? The 2 is only going to be applied to the things inside the parentheses. Now it's just business as usual. We have 1 sulfur and we have 4 oxygens, okay? And that's a total of, let's see, 2, 3, that's 15 total. Okay, so being able to look at a chemical formula, understanding how many atoms there are and what elements are represented is really important in chemistry. So hope that helps.